Structure of atom: atomic number, atomic mass number, isotopes, isobars, isotones, isoelectronics, isodiaphers, mirror nuclei. Few important terms I am going to explain now related to the atomic structure. First one, atomic number. Next one, atomic mass number. Next one, isotope, isobar, isotones, isoelectronics, then isodiaphers and mirror nuclei. So these terms I am going to explain now. First one, atomic number. Atomic number is nothing but the first term, atomic number. Atomic number it can be defined as total number of protons present in the nucleus of an atom is known as the atomic number. For example, hydrogen, its atomic number is 1 because it consists of 1 proton in its nucleus. Helium, atomic number 2 because it consists of 2 protons in its nucleus. Lithium, atomic number 3. Atomic number is the number of protons present in the nucleus of an atom. So one more thing, atomic number is represented by letter capital Z, and just I told atomic number is equal to number of protons present in the nucleus of an atom. An atom is electrically neutral, that's why total number of protons equal to the total number of electrons in an atom. When we are saying atomic number of hydrogen is 1, it means hydrogen consists of 1 proton and number of electrons are also 1. Helium atomic number 2 means helium consists of 2 protons and 2 electrons are revolving around the nucleus of helium. Atomic number is the characteristic property of an element. When we are saying atomic number 3, it means it's a lithium only. No other element having atomic number 3 except lithium. Atomic number determines position of an element in the periodic table. So there is a certain place for the lithium in the periodic table. The place is because of the its atomic number. Atomic number determines the space position in the periodic table. Next term, atomic mass number. Atomic mass number is nothing but the sum of total number of protons and neutrons present in the nucleus of an atom. Say for example, sodium atomic mass number is 23, magnesium atomic mass number is 24, calcium atomic mass number is 40. What it means? It means that actually sodium consists of 12 protons and sodium consists of 11 protons and 12 neutrons in its nucleus. Okay, and as we studied, the number of protons are equal to number of electrons. So 11 protons and 11 electrons are there. So atomic mass number is nothing but the total number of sum of number of protons and neutrons in the nucleus of an atom. In case of magnesium, we are seeing there are the 12 protons and 12 neutrons in the nucleus of magnesium. 12 electrons are revolving. So you may see here, what is the sum of protons and neutrons? 12 plus 12 24. That's why atomic mass number is 24. Same here, calcium 20 protons and 20 neutrons. So in case of calcium, the sum of protons and neutrons is the 14. That's why atomic mass number for the calcium is the 14. Atomic mass number indicates the approximate mass of an element. If we put unit AMU, it indicates the mass of single atom of the sodium atom. 23 atomic mass unit is the mass of single sodium atom. 24 atomic mass unit is the mass of one magnesium atom. It is not a characteristic property. say other atom of argon may have the atomic mass number 14. Okay, it is not a characteristic property, and it doesn't fixes position of an element in the periodic table as the atomic number fixes. So here I told about these two terms. Now these are the types of the nucleides. What are nucleides? Nucleides are the atomic species characterized by specific constitution of its nucleus. Means the nucleides consist of a certain specific number of protons and neutrons. So the first one is the isotopes. Here we are seeing isotopes, isobar, isotones. Iso term is get repeated. The meaning of iso, word iso is, iso means same. Okay, so we are going to use the term iso repeatedly in these all these definitions, upcoming definitions. Iso means same. What is the meaning of topes? Topes means position. Okay, so isotopes are the atoms of same elements having same atomic number but different mass numbers. Hydrogen atomic number 1, atomic mass number 1, hydrogen another atom having atomic mass number 2, and the one more atom having atomic mass number 3. We call them as a protium, deuterium and tritium. These are the isotopes having same atomic number but different atomic mass numbers. So many characteristics we may state about them. The two are there in its definition: same atomic number, different mass number, same number of protons they have, they are atoms of same elements, same number of electrons they have, their mass number is different one, their mass is different one, number of neutrons are the different one in these cases. Here no neutron in case of hydrogen. Deuterium there is one neutron, and in case of tritium there is a 3 minus 1 means 2 neutrons are there. Isotopes shows the same electronic configuration as the total number of electrons are same. First shell of all these consists of only one electron, and that's why distribution of electron is also identical. As the distribution of electron is identical, they shows the similar chemical properties. Isotopes occupies the same position in periodic table. There is only one place for the hydrogen. Okay, and they occupies the same place in the periodic table. Their chemical properties are also same. Why their chemical properties are same? Because they consist of equal number of electrons in their valence shell. Why they have a equal number of electrons in the valence shell? Because the total number of electrons are the same one, as their atomic number is the same one. This is about the isotopes. Now the next one is isobars. We know that iso means what? Iso means same. What is the meaning of bars? Bars means mass. So the atomic species which having identical mass, atoms of different elements, say example argon, potassium and calcium. Atomic numbers of these three are 18, 19 and 20 respectively, and their atomic masses are 40, 40, 40. So these are the isobars. Isobars are the atoms of different elements having different atomic numbers but the same atomic mass numbers. So characteristic easily we may state: atomic number different, atomic mass number same, atoms of different elements, number of protons are different, number of electrons are different, number of neutrons are also different. Here 40 minus 18, 22 neutrons, 40 minus 19, 21 neutrons, 40 minus 20, 20 neutrons. Isobars, they occupy the different positions in the periodic table. They have a same mass, and that's why their physical properties are somehow similar. Here in isotopes, chemical properties are similar one. Okay, now the isobars is over. Isotones. So we know iso means what? Iso means same. Isotones means the same number of neutrons. The species which having the same number of neutrons are known as the isotones. For example, neon atomic number 10, atomic mass number 20, and fluorine atomic number 9, atomic mass number 19. So number of neutrons is nothing but the A minus Z. Okay, A is the atomic, what we call here, A is the atomic mass number. Okay, A is the capital A is representation for the atomic mass number, Z is the representation for the atomic number. So in case of neon, 20 minus 10, there are the 10 neutrons. In case of fluorine, 19 minus 9, there are the 10 neutrons. So these two species having the same number of neutrons, that's why we call them as isotones. After isotones, The next term is isoelectronics. Iso, we know that is the same one. So what are isoelectronics? Isoelectronics means which the species which having the same number of electrons are the isoelectronics. For example, we know that neon atomic number 10, which consists of, here I'll write the electrons. Neon consists of 10 electrons. Sodium atomic number 11, which consists of 11 electron. But if I consider Na plus 1, means 1 electron is removed, 11 minus 1, 10. Here we have a magnesium atomic number 12. If 2 electrons are removed, 10 remain. Aluminium atomic number 13, total electrons are 13. If the 3 electrons are removed, Al plus 3 consist of the 10 electrons. Okay, here fluorine atomic number 9, but if one extra electron is added, fluoride ion if we are talking, so number of electrons are 9. Okay, now here I'll write the species. Say oxygen atomic number 8 consists of 8 electrons, but if we are talking about the oxide ion, so 8 plus 2, 10 electron. Fluorine 9 electron and one extra electron is there, F minus. Okay, now so that's why 10 electron. And here nitrogen atomic number 7, and if the 3 extra electrons are there, and the nitride ion if we are talking, so 7 plus 3, 10. So all these species are the isoelectronics because they having the 10 electrons in their valence shell. Okay, now after the isoelectronics, the next term is isodiaphers. Isodiaphers are the species for which the difference in neutrons and proton number is identical. Okay, here isodiaphers, I'll give the example. For example, carbon C613, suppose we are talking about the C613, N715 and the O817. So here I'll write first of all number of neutrons, then number of protons, then difference in number of protons I'll write there. Okay, so the number of neutrons are 13 minus 6, 7. Number of protons, atomic number means number of protons, here 7 and here 8. Number of neutrons are how much? 18 minus 15 minus 7, that is the 8. Here 17 minus 8, that is the 9. So these are the number of neutrons. Now the main thing, to which species we are calling isodiaphers? Those which having the n minus p difference identical and which is non-zero. Neutron and proton difference is the identical and which is non-zero. Now here neutron and proton difference, 7 minus 6, it's a 1, 8 minus 7, 1, 9 minus 8, 1. As in these three species, the difference in their neutrons and proton number is identical, we call them as a isodiaphers. And the last term, that's the, here I'll do on next page, mirror nuclei. To which species we are calling mirror nuclei? The species in which the number of protons and neutrons are get exchanged are the mirror nuclei. For example, 1H3 tritium and 2He3. Okay, let's check how many protons and neutrons are here. Here we have a 1 proton in hydrogen, helium we have a 2 protons. Okay, how many neutrons we have? 3 minus 1, 2. 3 minus 2, 3 minus 2, 1. Okay, so the number of protons and neutrons, see in the number of protons in first species, that is the number of neutrons in the second species. Number of neutrons in the first species, that is the number of neutrons in the second species. So such a nuclei are known as the mirror nuclei. Okay, so the things are very easy. Let's recap briefly. Atomic number, that total number of protons in the nucleus. Atomic mass number, sum of protons and neutrons, atomic mass number. Isotopes, atoms of same elements having same atomic number, different mass number. Isobars, atoms of different element, different atomic number but the same mass number they have. Isotones consist of same number of neutrons. Isoelectronics, having the same number of electrons in them. In case of isodiaphers, they the difference in n and p is the identical one. Neutron and proton difference is identical. And the last one, mirror nuclei, are the species in which the number of protons of one species, that is the number of neutrons of the another species, and vice versa. Okay, Bye all of you. Thank you.